Studying ecosystem ecology without incorporating humans is no longer an option. Here, we'll examine some of the changes in human populations that set the stage for the large influence of humans on the modern Earth ecosystem. The rising human population and its consumption of resources account for many recent changes in the Earth's system. When we start to take a look at how humans have influenced the Earth, we tend to start within the Holocene. Now, the Holocene is an era that really incorporates the past 10,000 years. Within the Holocene, some people have actually said that we've now entered a new era, and that's called the Anthropocene. And it's the modern era, which doesn't necessarily have a defined starting point, but it starts somewhere around the Industrial Revolution. And the changes that humans have made to the Earth system recently those changes qualify as really being a unique geologic era. When we take a look at different patterns, things really changed somewhere on the order of 150 years ago. And that deserves its own special category, and that we call the Anthropocene. The Holocene, the past 10,000 years, is relatively unique in that it tends to be a period of stable, warm temperatures. So we know that there's been ice ages all throughout the past few million years, and there's been large changes in Earth's climate throughout its entirety. When we take a look at some of the patterns that we see, there's two panels here, and this is figure 14.2. We'll deal with the bottom panel first. This shows time, and this is in kiloyears before present, so that's thousands of years. And here we're talking, if this is 100, we're going back 100,000 years. On the y-axis, we have a temperature anomaly, which really says relative to a standard, how much variation is there in the temperature. It's not an absolute temperature on a global scale necessarily, but it shows the variation in temperature for a place that's been measured. And these data come from oxygen isotopes. These oxygen isotopes were laid down in ocean sediments and represent not necessarily a global temperature, but are indicative of changes in global temperatures. So we can start to get a pattern for what temperatures look like on a global scale. If we go back and really move forward, so if we go back to 100,000 years, the pattern you can see has a lot of fluctuations. And there's periods that are warmer and periods that are colder with a lot of variation. What's unique is really the past 10,000 years that have been pretty constant, and more constant than really any other period that we've seen if we're looking at over a 10,000 year period, and they've been a lot warmer. Now there's different factors that are affecting global temperatures, but we can see that this Holocene is really a unique period in that those temperatures are stable, there's not much variation, and they're warm. Now this scale right here being 10-20 degrees Celsius, that's somewhat of a different scale and shouldn't be thought of as global temperatures being 10 degrees C lower, but it's indicative of global temperatures. The top panel shows a different temperature reconstruction. And again, we have a temperature anomaly on the y-axis. On the x-axis, we have year, so it's not years before present, but this is actual year, with modern being 2000 and going back over 1,000 years. And this temperature record more than likely is a multi-proxy record. It comes from a lot of different sources, but it's quite often tree rings, for example, that are used to generate what the temperatures were like in the past at a relatively high resolution. And what you can see is that again there's variation, and there's different periods that we can see of slightly warmer temperatures and slightly colder temperatures. So the period that we consider the medieval warm period, which is a phenomenon that was present in Europe, for example, is slightly warmer temperatures. And then the little ice age here are slightly lower temperatures. And you can see that if we take a look at temperatures over the past 150 years, they've really exceeded anything that we were able to reconstruct over the past 1,000 years. And when we take a look at the past, go back to 100,000 years ago, again, the temperatures that we see, and this doesn't show up too well, are a lot higher than anything there. So we're seeing changes in global temperatures that are occurring, and this is some of the most contentious records that are being put together scientifically. But what's clear is that Holocene is 10,000 years of stable, warm temperatures. During this time, human population increased somewhere on the order of 1,000-fold. So if we go back and we take a look at the past 10,000 years at what populations were, here's billions on the y-axis. This is a reconstruction of it. You can see that there's really an exponential increase and that they were relatively low even 2,000 years ago. And then somewhere around the Industrial Revolution, we had an exponential increase in world population. And even as, on the order of 100 years ago, we were still at 1 billion. Since then, we've added 6 billion people to the planet. Now, within that period of the Industrial Revolution, we think of 1950 as really the start of what by some people is called the Great Acceleration. And it's an acceleration in population growth, but also a lot of other things too. So this is a different reconstruction of population. You can see that this is a log scale on the y-axis, and here's time, which is a linear scale. Here's year 2000, here's year 0, and then going back to 10,000 years before. And again, these are reconstructions of what we think the populations were like, for example, and we don't really hit 1 billion until relatively recently, and 100 million at year 0, we were just over somewhere on the order of 200 million people on the earth. So there's been changes, and you can see that really things take off somewhere on the order of 1950, and that's what we think of. And over this period, so going back to thousands of years ago, we've added 1,000 times more people than there used to be on the earth. And really we have somewhere on the order of 1,000 times the effect of those people, if not more. So just adding 1,000 times more people, you're going to increase your impact on 1,000-fold, somewhere on that order, but probably even more. As those populations have grown, and we've changed not only the quantity of people on the earth, but also qualitatively how we interact with the environment. Agriculture is different today than it used to be. The way we extract resources is different, and we're extracting resources, for example, and also adding different resources to the environment in ways that we never did before. So quantitatively it's different, and qualitatively it's different. And it's become of the magnitude that it's impossible to study the global ecosystem without directly incorporating humans. Explanation of ecosystem function requires explanation of humans. Whenever we're taking a look at how ecosystems function, for all the different reasons that we talked about, quite often we have to include humans as a state factor and also an interactive control. It doesn't mean that everything about an ecosystem is determined by humans, but they're a predominant force, and they're affecting so many facets that we have to, if we want to explain how ecosystems function, then we have to include humans. The flip side of this is that predictions of ecosystem function require predictions of humans. And this is, once you realize this, it really changes ecosystem ecology also. Because before we were just thinking about the pools and fluxes of energy and materials, and those state factors could exclude humans. But if we want to predict how ecosystems will function in the future, we also have to predict how humans are going to function. And that really expands the boundaries of ecosystem ecology and brings in new disciplines into and allies them with ecosystem ecology in order to make those predictions. Because we can't predict what the Earth ecosystem or any one ecosystem is going to be like until we get a good, robust understanding of how humans work and include them in our predictions too.